Hey everybody, today we're doing a review for the final exam, and I'm going to go through the questions that dealt with factoring, solving equations with factoring, working with polynomials, and rational expressions. So this comes from the review that was given out a little bit earlier, and let's just go through it, okay? So right away, you got to read carefully before you start the question. Don't just start blindly calculating. The example says that the rectangle has an area that's equal to 8x squared plus 20x square centimeters, and the perimeter is 70. Now, the typical mistake is to put those two guys equal to each other, and you can't because the area and perimeter are obviously different values. But the concept of given an area, you know that area is base times height. And so if we can turn this binomial into a multiplication, then we're going to have the base and the height. And here's where you have a gift because the 4x is given. And so it's just a matter of it's partially factored, and you have to figure out that second bracket. You could do this with trial and error, guess and check. But when you multiply the 4x times the 2x and the 4x times the 5, you're going to get the 8x squared plus the 20x, which means that the other dimension must be 2x plus 5 centimeters. When we now have to find what the value is for x, and remember, whenever it asks for a numerical value, it means you're going to solve for x. So you're going to take the perimeter of this rectangle and make it equal to 70. So perimeter is going to be 2 times 4x plus 2 times 2x plus 5, right? 2 bases, 2 heights. And that's going to have to equal to 70. So it's kind of weird. It's not going to wind up as a quadratic. You're going to expand that bracket and just solve for x. So 12x is equal to, I'm going to bring the 10 and subtract it. That's going to be 60. And you divide through by 12. Always divide by the coefficient. X equals 5. And now it asks you for the area of the rectangle. So basically, you know the area is 8x squared plus 20x, or you could actually use the factored version of it and replace in 5 for your solution following proper order of operations. So 25 times 8 is going to be 200 and 100. So the area is equal to 300 centimeters squared. The next question is also about area, this time for a triangle. And so if it had just said find an expression for the area, you would go base times height divided by 2. However, there's that word again. They want the numerical value of the area. So that means we're going to have to figure out what x is. Now, we don't have any clues about perimeter or the area value, but we do know a right triangle is going to follow the Pythagorean theorem. And the Pythagorean theorem, you can set it up any way you want as long as you have the hypotenuse on the side by itself. So I'm going to set this up as x squared equals 8 squared plus x minus 2 squared. And it's really important to put that in a bracket. Expand the bracket, and remember that when you square x minus 2, it's going to be a trinomial, right? You're going to have to do FOIL to multiply out that bracket. And so that's going to equal, and I'm going to skip a step here, x squared minus 4x plus 4 when you would work that out. I got to bring everything to the same side. That's the way we normally are going to solve a quadratic. And so I'm going to bring it, it doesn't matter which side I bring it to because they're both 1x squared. So I'll bring it to the right, and that's going to be x squared minus x squared. Notice I'm putting it into proper order here of the terms. And since the x squareds cancel, 0 equals negative 4x plus 68. Now you have two choices at this point. You could factor this bracket, factor out the negative 4, and then treat it like a quadratic. Or let's go back to the way we would do it in grade 7, where we bring the letters to one side and the numbers to the other and divide through by the coefficient. X is equal to 17. Remember now, you have to find out the numerical value of the area. So I'm going to have to replace that in. Area equals base times height divided by 2. And so x equals 17. 17 minus 2 here is going to be equal to 15 centimeters, I believe. And it doesn't actually have units. So it's going to be 15 times 8 over 2 equal to 60. And it doesn't have units, so I'll just say units squared. I've already started off question 7. There's a lot of symmetry going on here, but be careful because although the three sets of multiplications might look the same, they're going to differ in the way that they're handled. For example, this first one, they're both plus 4s in both of the terms. So you're going to wind up with 25x squared plus 20x plus 20x. That's going to be 40x in the middle, and 4 times 4, positive positive, is 16. Now the second part, I can't forget about the negative sign in front, so I'm going to leave my answer here in a bracket. And this time it's going to be negative 20x and negative 20x, so my middle term is negative 40x. And the negative 4 times the negative 4 is still going to be a 16. And my last term, you might recognize this as a difference of two squares, okay? If not, well, you can work it out and you'll see that the middle terms are going to cancel. It's going to be 25x squared, and the plus 20x, the minus 20x cancel, and that's going to be just negative 16. So we'll remove the brackets, and in the next line we'll do a cancellation of the terms that cancel. That shouldn't be 25 squared, by the way. Let's fix that. It was 24x squared minus 40x. Now when you're removing the bracket here, you've got to bring the negative into all of the terms, so that's going to be positive 40x and negative 16, and 25x squared minus 16. So I got a positive 25x squared and negative 25x squared. I got a positive 16 here and a negative 16. Now, interestingly enough, those 40x's didn't cancel out. They're actually going to combine. So that's going to give me 80x and the leftover negative 16 at the end of it all, right? Let's make sure I got them all. I got the 25x squared, I got the 40x's, and the negative 16 at the end. And remember, by the way, I should have mentioned this at the beginning. When I say simplified expression, you're not expecting to find out the x, right? If it says solve or it says the numerical value, that's where you're going to have to find out the x. Moving on to question 8, this is asking you to simplify this rational expression, okay? And the way we do this is to do lots of factoring and make sure cancel out only brackets that are identical. So in the top of the first fraction, that's a GCF. You can take out a 2x, leaving you with x plus 3. In the bottom, that's a simple trinomial. Remember, simple trinomials, you don't have any other choice but to put 1x and 1x. Then we look at the factors of 20 that are going to subtract to give us a positive 1. So it's going to be 5 and 4 or 4 and 5. I like to put the bigger number first, and that means it's going to have the same sign that you see in the original. And the signs are different because it's a negative 20. You'll have to review those details about factoring if you don't remember them. The next question, the top right here, I rewrote it as rectangle squared minus circle squared. And this is the way of kind of picturing what goes on when you have a whole bracket squared. That's the rectangle. So I would put my answer as bracket plus 4, bracket minus 4. X plus 1 plus 4, and x plus 1. Notice it's still plus 1 minus 4. And big ugly brackets around that. Okay, and we'll clean that up in a second. And on the bottom, that's a difference of two squares, x plus 3, x minus 3. Yeah, so I'm going to take the extra line just to clean everything up with proper bracketing, and then the cancellation can continue. As I said before, you can only cancel brackets that are identical. So let me go for a different color here and say the x minus 3's are going to cancel, the x plus 3's are going to cancel, the x plus 5's are going to cancel. And you might want to cancel the 2x and the x minus 4, but this is where the brackets kind of remind you that you can't, because the 2x is a multiplication, the x times the 2, but the x in the bottom is a subtraction. So you can't do any canceling. That's your final answer in that question. Looking at number 16, this is a square and a rectangle that are equivalent. They have the same area. So the square, the two sides are going to be x and x. So the area is x squared. And the rectangle is going to be the product of those two binomials, 7x minus 32 times 3x minus 16. Now, since they're equivalent, that means they must be equal to each other, and we can set up a quadratic equation for this. X squared equals 7x minus 32 times 3x minus 16. And you just have to expand the brackets and bring everything to one side. So on the right side, you're going to get 21x squared minus 112 x minus 96 x and positive plus 128, I believe it is. 16 times 2 to the d6, 512. And bring everything to the same side. So I'm going to bring the 21x squared, sorry, the x squared with the 21x squared. So it's going to be 20x squared minus, these guys together are going to be 208x, and the last term is 512. This is a ridiculously big trinomial to factor. Fortunately, there's a GCF, and if you don't take these GCFs out, your factoring is going to be a lot worse. So 5x squared minus 52x plus, this is going to be 128. Now, a little bit of fiddling with the numbers. You put your factors for 5, and you put your factors of 128, and you're looking for the pair that's going to add to give the middle term of negative 52. So notice, by the way, these are only going to be powers of 2 when we're working this out. And the pair that works is going to be 5 multiplying with the 4 and the 1 multiplying with the 32, 20 plus 32. So my first bracket is going to have the 1 and the 4, and my second bracket is going to have the 5 and the 32. And you dress them up with the x's, and in this case they're both going to be the same sign. They're both going to be negatives. Now your two solutions are going to come out of those two brackets. X is either equal to positive 4, or it's going to be equal to the opposite of the constant over the coefficient, so 32 over 5. Now there's a lot of discussion we've had about which of these two answers is right. Unfortunately, if you were to plug in the x equals 4 into the second one, you'd get 3 times 4 minus 16, and that's going to give you a negative number, so that won't work. So x must be equal to 32 over 5, which in this case it's probably better to put it into a decimal form because we can work on this, all right? And I'm not going to finish this question off. That's going to be up to you for the perimeter of the rectangle, just for the sake of time in this video. Question 17 is similar to the other one that we did with the right triangle, Pythagorean theorem, and you would basically go the hypotenuse squared 2x plus 6 squared is equal to the sides squared and added together. And remember, you have to follow the order of operations. Now, I'm not going to finish this question either, but I will remind you that multiplying these out means you have to FOIL pairs of brackets, whoops, and you have to expand and then bring all the like terms together. So this is a pretty meaty question that hopefully you can figure out not too painfully, okay, for all of the brackets. And as I said before, I'm not going to be finishing this off because I only got about 1 more minute in this video. Okay, there's a 6. Pause. Last question I'm going to talk about. We only got about 40 seconds here. I had to factor all of the parts of the expression, and the complex trinomial is a bit of a task, so that one you're going to have to review for sure. Remember that you had to flip the fraction after the division, and then we cancel the parts that match identically, so the 6x minus 1 and the x plus 2's, and you're left with 6x plus 1 over x plus 4 for your final answer. So hopefully this was helpful, and you can go back and watch the parts of this question, these questions that you didn't understand. Thanks, and I'll have another one for the rest of the questions.